Hello students. In Bohr's atomic model from the atomic structure, we need to think of the Bohr's model for hydrogen atom and hydrogen-like atom. In both of them, if we think of the electron revolving around nucleus, this is nucleus, and in hydrogen atom, one electron is revolving. When it is revolving, it has angular momentum. Angular momentum is defined as product of mass, velocity, and radius of that electron. MVR is always quantized to h by 2 pi, means integral multiples of h by 2 pi, whereas n is the principal quantum number. You can simply consider that as the order of the orbit, first orbit or second orbit, first energy level or second energy level, like that. If it is ground state, n will be 1, first excited state, n will be 2, like that. And in hydrogen like atoms also, what are the hydrogen like atoms? He plus, actually hydrogen has 2 electrons around that nucleus, right? If we remove one electron, that is also acting like hydrogen like atom, because though it is a helium nucleus, it has only one electron, just like hydrogen. Now if we think of Li plus plus, means again I take lithium nucleus, around that lithium nucleus 3 electrons are revolving, like that. If I consider, if I remove 2 electrons, then we are ionizing it twice. If I remove 2 electrons, then what you observe? You observe again, this is also acting as a hydrogen like atom, means this is also has just one electron, so we call it as this is also hydrogen like atom. Okay, now for hydrogen like atom also, when one electron is revolving around this, whether it is hydrogen or hydrogen like atom, this first condition is same. Angular momentum is always quantized to h by 2 pi, again that, and here it is a order of that orbit or order of that energy level. Ground state, n is equal to 1, first excited state, n is equal to 2, like that. Next, if we think of any revolving object, any revolving object requires a centripetal force called as mv square by r or m r omega square. Everyone knows this, right? Means if you consider a simple example like this, if you take a buffalo, if you say it to rotate, it cannot rotate. If you tie that buffalo and if you release that, it may revolve like this. The thread is providing the necessary centripetal force on that. Now in the same manner, if we think of earth rotating around sun, that also requires a force to rotate. If there is no such force, no object will rotate, right? Now there, in the case of earth and sun, the necessary centripetal force will be only the gravitational attraction force. In the case of buffalo, when it is rotating around its center, the tension in the thread, it is acting as centripetal force. Now we think of the case of electron. When electron is revolving, it should also require some centripetal force, and that centripetal force is nothing but electrostatic attraction. In 10th class, you have already learned that electrostatic attraction force between two charges, it is equal to q1 q2 by distance square, 1 by 4 pi epsilon naught into q1 q2 by distance square, right? So if you are unable to retrieve that formula from 10th class knowledge, no worries, because we are working very much extensively in the case of second year electrostatics, right? So you don't need to worry about this one. There the force of attraction between the two objects, it is equal to 1 by 4 pi epsilon naught into q1 q2 by r square. So when two charges you place like this, q1 into q1 and q2, the force of attraction between them is always directly proportional to product of the charges, and inversely proportionate to square of the distance between them, directly proportionate to product of charges, and inversely proportionate to square of the distance. Now we are using the same formula here. Here, if it is hydrogen atom, hydrogen nucleus has E charge and electron also has E charge. So Q1 is E and Q2 is also E. Then E into E, E square. 1 by 4 pi epsilon naught into E square by R square. Now we think of whether it is Li2 plus or Hg plus, we are thinking of hydrogen-like atom. In the case of hydrogen-like atom, the nucleus has Ze charge because nucleus has Z protons, right? So that each and every proton is having E charge, so the total charge it is Ze. Means if it is helium, 2E, if it is lithium, 3E, like that the nucleus contains the charge. Now in this case, what is the force of attraction between them? It's 1 by 4 pi epsilon naught into E. In place of Q1, what you need to write? Q1, it is charge on electron, E. In place of Q2, what you write? Ze. If it is helium, 2E, lithium, 3E, like that. So that will be converted into 1 by 4 pi epsilon naught into E into Ze. Ze square by R square. Again the same formula. Only the difference between that hydrogen atom and hydrogen-like atom, the centripetal force can be considered just like this, here like this. The only difference it is there one extra element like Z, we are including Z, right? Check, have a glance on that, right? Next, we think of centripetal force required for electron, right? Centripetal force means every rotating object requires a centripetal force. If you simply say a buffalo just to rotate, it won't rotate. You need to tie that buffalo to a thread and you need to allow that, right? Now, here from this, if you consider that mv square from here, I can cancel this 1 r here and 1 r here. Then I bring this r here. Then mv square r is equal to E square by 4 pi epsilon naught. And for hydrogen-like atom, it is mv square r is equal to Ze square by 4 pi epsilon naught. Right? Only difference it is here wherever it is E square it is existing, here an extra Z will exist. Ze square. After that, V is equal to E square by 2 epsilon naught h. How you got that? Just divide this 3 with this equation 1. You got like this. Here also divide this 3 with equation 1. Then what you get? You will get it as a Ze square by 2 epsilon naught h. Here also only the difference it is extra Z, right? So everywhere you are finding that extra Z here. That's it. Just here you find only E square. There you are finding Ze square, like that. Substitute this fourth equation in 1, then you get radius as n square h square by epsilon naught and by pi mg square, and this is exactly equal to 0.53 n square. Now here also the same thing, but here this could be 0.53 n square by 0.53 n square by z is also existing, right? N square by z. Okay, like this we can consider that radius means the radius is directly proportionate to n square here directly proportionate to n square by z. In the same manner, now we think of the potential energy. So you might not learn this potential energy in 10th class, right? So just like that force between two charges of F is equal to Q1 Q2 by 4 pi epsilon naught is that attractive or repulsive force. Like that, between two charges there exists some energy, right? The potential energy will be 1 by 4 pi epsilon naught into Q1 Q2 by R. Force will be Q1 Q2 by R square. Energy will be Q1 Q2 by R. Now here also Q1 and Q2 are E. That's why you get like this. And minus indicates that there is an attractive force between nucleus and electron. This minus indicates there is a bondage between the revolving electron and nucleus. Here also the same way, but extra z. Minus z is squared by 4 pi epsilon naught r. So you should consider that the minus always indicates that there is a bondage between electron and nucleus. If you make this negative value to either to 0 or a positive value, the electron will not be bound to that nucleus. That point you need to remember, right? Now, after this, you just again compare that hydrogen atom and hydrogen like atom. In this, now I introduce the total energy. Total energy for hydrogen atom, it will be sum of potential energy plus kinetic energy, right? If you add those two, potential energy is positive and kinetic energy, it is potential energy is negative and kinetic energy is positive. Now, if I add, I get minus e square by 8 pi epsilon naught r. That also indicates, the negative total energy indicates there is a bondage, right? If you make the total energy negative, that is, we are finding the bondage between nucleus and electron. If it is possible to make the total energy as positive, there that electron won't stay in the vicinity of nucleus, right? Now putting that radius value here from this equation, if you put that radius value, the total energy becomes this much, and you need to remember that total energy is always equivalent to minus 13.6 by n square electron volts. This is the very important relation. In the same manner, with hydrogen like atom also, the total energy will be just minus Ze square by 8 pi epsilon naught r, and substituting that r value from there, it is minus mz square e power 4 by 8 epsilon naught square n square h square. And the important point here, it is just minus 13.6 z square by n square electron volts of total energy it will have, right? Okay, take the notes.